Okay, today we're going to be going through some more simplification of surds. So to start off with, we're going to look at rationalizing the denominator of surds. So here you can see we have a surd on the bottom of this fraction. Now, to simplify these expressions, we need to actually rationalize that denominator. So the way we can do that is we multiply this whole thing by the base of that fraction. So we do square root of 3 times square root of 3, and then the square root of 7 times the square root of 3. So if we do that, do it down here. So if we look at the top first, so we have 7 times 3, so it'll be the square root of 21 divided by, so square root of 3 times by the square root of 3 is actually just 3, okay? So if you have two square roots of the same number and you multiply them together, they'll give you the same number, but the whole number, not a square root. Okay, so our final answer for the simplification would be root 21 over 3. So now let's have a look at this expression here. So we can also minus and add surds as well. So if we have the same number in the surd, like for this one they're all root 5, then we can just look at the coefficients. So remember, if there's nothing at the front of this first one, that means there's a 1 here, we just don't write it. So if we pretend there's a 1, so we go 1 minus 2, okay, negative 1, negative 1 plus 4, we get 3. So if we just deal with these front things, the coefficients by themselves, then we get 3, and then that root 5 stays the same. So that's another thing you can do with surds when it's the same number in the actual root. Now, multiplication is a little bit different. So we can multiply surds even if they have different numbers here. So this one's root 3, this one's root 11, but we can still multiply them. So the way that works, we multiply the 2 and the 5, and we multiply the 3 and 11. So we get 2 times 5 is 10, and then root 3 times 11, which is 33, okay? So that's a simplified version of that expression.